Hey everyone, today I'm going to be talking about if wireless power is actually possible. Did Nikola Tesla actually invent something that was able to transmit wireless power to the entire planet? And I'd like to thank SimpliSafe for sponsoring this video. I'll tell you more about them later. In order to understand how Nikola Tesla wanted to transmit power, first you have to understand that it's pretty easy to transmit power wirelessly. For example, all you need is a balloon and a piece of paper. So I'm going to charge this balloon up by rubbing it on my floor. So watch what happens when I bring the balloon near the paper. The paper goes towards it. So now let's say I wanted to generate some type of power by wiggling this paper back and forth. Well, then I just have to move my balloon by it back and forth. You can see that you can easily transmit power, meaning it took some energy to move this back and forth and back and forth. So I transmitted power from the balloon to the paper. And I did that by alternating a current, meaning that I had a static charge here, but I was moving it back and forth and back and forth, and that was moving the paper. So by moving a charge back and forth and back and forth, you can transmit power. And so what we need to do to transfer energy is to move charges back and forth and back and forth. Now, instead of moving a balloon back and forth really fast, let's use something a little bit easier, like a piece of wire. Because pieces of wire already have electric charges in them, we just have to figure out a way to wiggle the charges back and forth. And one way that we can do that is by putting an inductor in it. So an inductor is just a coil of wire. And then if we connect that inductor to a capacitor, what happens is that if we apply a voltage to it, an inductor and a capacitor together sort of act like a swing that swings the voltage back and forth and back and forth. So if we apply a voltage to it, the voltage will go up and down and up and down and up and down and eventually dampen out. And the specific frequency that this voltage oscillates in here, so meaning that the frequency at which the current goes back and forth, or the electrons move back and forth in here, is called its resonant frequency. So now if we get electrons wiggling back and forth in this circuit with this specific frequency, we know that it will also wiggle other charges in the area. Just like when I wiggled my balloon back and forth, it moved the charges on the paper, so it was able to wiggle the paper. So if I put another circuit near it that was exactly like this one, what would happen is it would also cause electrons to wiggle back and forth in this wire. And the way a Tesla coil works to step up the voltage is first it uses more turns of wire in this inductor than this one. And so that steps up the voltage. And what's really cool is if you get another circuit that has the same resonant frequency as this one, you can basically step up the voltage very high so that with each additional swing of the voltage, you can push the voltage higher and higher and higher till eventually you get extremely high voltages in this wire. And this is basically how a Tesla coil works. It steps up the voltage from this wire to this one so that you get extremely high voltages. And you can see there's not a capacitor here, but it really is a capacitor because the Tesla coil is grounded and then it has an ungrounded ring up top here, or a wire up top here, which essentially acts like a capacitor. So the Tesla coil produces very high voltage at really high frequencies. And so it's a high frequency, high voltage spark at the top here. So this means that even though this Tesla coil is producing voltages in the tens to hundreds of thousands of volts range, it means that I can touch it and not get shocked. So I can even touch it with a conductive knife here, and I still don't get shocked. So that doesn't mean that there's no current going through me, but what it means is that because this is at such a high frequency range, all of the electrons are not going deep into me, but they're only transferring on my skin. This is called the skin effect. Whenever there's a transfer of current at high frequencies, it only travels on the skin of the conductor. And so in this case, the knife and me are the conductor, and so it's traveling only on my skin, and so I don't feel the electrons going through me. I don't feel the electric shock. Now it will still burn me, so I can't touch it for long, but it doesn't shock me. And what's really cool with a Tesla coil like this is you can add an interrupter into the circuit, which can add a music signal into the arc discharge from it. So into the sparks, you can get a music signal to form because you hear the sound from the sparks, but it's put to the beat of the music, and so it sounds like it's a speaker. So there's the spark. I turn on my music. So the music is actually coming from the pressure changes of the arc discharge on top. So the pressure changes due to this spark are causing the music. And because there's a high frequency alternating current in this coil here, that means it's sending out an alternating electromagnetic field through the atmosphere. So that means that if you have something that can use an alternating current, then you can use the power from this device and obtain it wirelessly into the device you want to be powered. For example, this light bulb here. So you can see that when I bring this close to it, it powers up. And the closer I get to it, the more it powers up. And what's interesting, you'll notice that when I bring it near it, the spark at the top goes away. So this isn't free energy at all. I'm actually taking away the energy that is just getting discharged through the top there. When Nikola Tesla invented the first Tesla coil, it was very clear that power could be transmitted wirelessly. He was famously known for walking around with fluorescent bulbs in his hand near Tesla coils and showing how they could be lit when he just holds them in his hand. But the problem with this system is it relies on near-field electromagnetic waves. And what that means is when you increase the distance by 2, that means it decreases the power by a factor of 64. So that's why my light bulb doesn't light at all when it's here, but when it's here, it lights up fine. Now, if Nikola Tesla was such a smart guy, why is it that he went on to try to build this Wardenclyffe Tower when he knew about that power decrease with distance? Well, there's a few reasons why. Now, let me explain what he was trying to do with his Wardenclyffe Tower. Now, here's what Tesla was envisioning for global wireless power. Now, imagine we have a sphere here filled with liquid, and we have some pressure gauges throughout the globe here. And right here is the pump. You can imagine that when we push this pump down, all of these pressure gauges will go up at the same time because the pressure wave will travel from the pump here and it will go down and it will resonate through this entire globe here. And eventually all of the pumps will feel that pressure wave go through and it will make all of these needles go up in the pressure at the same time. And this specific globe would have a specific resonance frequency, meaning that when we push this pump down, down, down at a specific frequency, if we got the frequency just right, that means that we could build the pressure waves up higher and higher and higher, so that with each additional pump, the pressure wave would get higher. Kind of like pushing on a swing. If you push it just the right time, you can get that swing to go higher and higher and higher. And so by using these pressure waves through this globe here, and by using the resonant frequency, you could get a global transmission of power. But instead of fluid, Tesla envisioned using electric charge, and he wanted to use Earth as the giant ball. So instead of pumping fluid into the ground, he would pump current into the ground. And he said that the current should travel through the earth in these longitudinal waves, and it would resonate with the earth and bounce back and forth and back and forth. So Nikola Tesla was trying to build this Wardenclyffe Tower that was attached into the ground that was supposed to pump these currents of longitudinal electromagnetic waves into the earth. And he wanted to find the resonant frequency of the earth so that these waves would resonate back and forth and build up more and more power so that they could fill the whole earth. And all you would have to do was plug into the ground at any point on the whole earth. And that's how he wanted to transmit power wirelessly. But the problem with this analogy is this one used water, but this one uses electricity. Water can have longitudinal waves, but electricity cannot. And if you've never heard of a longitudinal wave, basically this is a longitudinal wave, and this is a transverse wave. So the transmission of pressure waves or sound through solids or liquids can be transverse and longitudinal. But the transmission of electromagnetic waves through a solid or through just total vacuum is always transverse and never longitudinal. But the problem is Nikola Tesla didn't believe this, or didn't want to believe that there was no such thing as longitudinal electromagnetic waves. Now, the design for Tesla's wireless power basically had to be pieced together after he died. Tesla was notoriously known for not putting all the details into his patents because of the culture that he lived in back then, where people were stealing his technology left and right. But Nikola Tesla was an amazing genius that seemed to see beyond his own time. In fact, he made an eerie prediction before he died. He said, "When wireless is perfectly applied, the whole earth will be converted into a huge brain," which in fact it is, all things being particles of a real and rhythmic whole. We shall be able to communicate with one another instantly, irrespective of distance. Not only this, but through television and telephony we shall see and hear one another as perfectly as though we were face to face, despite intervening distances of thousands of miles. And the instruments through which we shall be able to do this will be amazingly simple compared with our present telephone. A man will be able to carry one in his vest pocket. Sounds familiar, doesn't it? So it may be that we just have not grasped what Nikola Tesla was trying to invent with the Tesla Tower or the Wardenclyffe Tower. And again, I'd like to thank SimpliSafe for sponsoring this video. When we purchased our house, I really wanted to make sure that my family was safe and that we could have peace of mind when we went on vacation or anything. And that's why I purchased the SimpliSafe security system. And when they sponsored this video, they gave me an upgraded system, and it's awesome. SimpliSafe is an incredibly reliable, effective home security system. Everything is monitored by professionals 24/7, and they'll call you in an emergency and send police help if needed. And one thing I love about SimpliSafe is how easy it is to use. So with the new system they sent me, I had it out of the box and set up within about 30 minutes from opening it. You can see I have some glass break sensors, entry sensors, motion detectors, and my camera. And I really like how SimpliSafe has fair and honest prices with no contracts, no hidden fees. And I really like that SimpliSafe is equipped for worst case scenarios. For example, this whole SimpliSafe system doesn't need Wi-Fi, it doesn't even need the internet to function, and it doesn't even need power. Everything can be battery powered on backup if your power goes out. So head over to simplisafe.com/actionlab. I'll also put a link in my description to check out the SimpliSafe security system. Now right now, SimpliSafe does only ship to the US, but they're looking to expand very soon now. So thanks again for SimpliSafe for sponsoring this video. And if you haven't subscribed to the Action Lab yet, remember to hit the subscribe button, hit the bell to be notified when my latest video comes out, and head over to theactionlab.com if you haven't checked out the Action Lab subscription box yet. And thanks for watching, and I'll see you next time.